Hello, it's Keith here, and this is Lesson 84 of the platform-specific series of my Z80 programming tutorials. And it's not quite the Z80 today because we're working on the Game Boy with its weird pseudo Z80 processor, which I refer to as the GB Z80. Now, what we're looking at today is what I refer to as Mintile. Now, this is a multi-platform tile map which simulates a tile map on bitmap-based systems, and it also simulates sprites. Now, today we're using a real tile map-based system, so it's not simulating the tile map, but it is simulating the sprites. The Chibico character here, that's my mascot up there. That is not being drawn with sprites, that is actually just being drawn with tiles, and so it's moving in rather chunky movements. But the benefit of this is we don't need to worry about how many sprites are on screen because we're not using them. So we've got our character here, and the trick that this has got is it's got X flip, so our character can turn around without needing any more pattern data. And for this reason, the example you can see here requires the Game Boy Color. Now, the code does actually work on the Game Boy, but it's a little bit glitchy. It's not been tested, and the X flip doesn't work because that's a Game Boy Color function. But anyway, it does at least work to some capacity. So that is what we're going to be looking at today. So let's go over to our source code and let's check it out. Okay. So here's the source code for what we're looking at today, and let's check out what actually is involved in the code. So Mintile is a multi-platform system, and most of the code is multi-platform. So the only part we're looking at today is the actual tile drawing routine. There's a separate tutorial series on the multi-platform code if you want to see how the tile map is calculated and how the simulated sprites are sort of built up and things. But what we're going to be looking at today is the actual drawing routines for the code itself. So basically, there's not too much that's very interesting here. We've got some code here that just transfers the tile data from the cartridge to VRAM. This is very similar, well, I think it's actually identical, truth be told, to what we've done before. Basically, all we're doing is we are reading in a byte from our source, writing it to our destination using that Game Boy special LDI command, very nice command there. We've got an LCD wait command here, which just checks that the LCD isn't doing anything because we can't access VRAM outside of H or V blank. So that's just transferring our data to the VRAM. We're setting up palettes and other things here that we've done before. We're not going to cover the stuff that's not new because I'd be repeating myself in all of my tutorials and I would go completely insane. Now, the way that the Mintile routine works is it's got a sort of platform specific routine called doStrip. Now, what this does is it draws a single strip of tiles to the screen. Now, if we want to draw an entire screen or a little sprite, a simulated sprite, what we do is we split it up into strips. So we draw the strip along the screen, move down, draw the strip along the screen, move down until we've drawn our entire screen. And that gives a nice balance of multi-platform code that doesn't need rewriting every time and platform-specific code that does need rewriting every time. But I think this gives a nice minimal set of functionality. And I should point out that this is called Mintile. I'm working on a more advanced version called Maxtile, which will allow for a lot better stuff, including hardware sprites and X and Y flip and various other things. Various bug fixes as well that I found while I was writing this. So let's take a look at the code today. So here is the doStrip routine. Now, on the normal Z80, we are using shadow registers. This system does not have shadow registers, so we've got some areas of memory that we're using for shadow registers, and the other missing register, the IYL register that we use as our tile count. So when you see RS, that stands for register shadow. So this is effectively the equivalent of the shadow registers here. So what we're doing here is we are loading in the shadow register BC, simulated shadow register I should say, and this is the address of our tile map on the other system, on the other Z80 systems. And then what we're going to do here is we're loading in the tile clear flag because on some systems we use self-modifying code. This is running from ROM, so we're assuming we can't do that because unless we transfer to RAM, we definitely can't. So we're loading that in for later. And what we're doing here is we're loading in the tile number into the accumulator from the tile map that we're being asked to draw. Now, with Mintile, a tile number of 0 has a special purpose. If it's a part of a sprite, that means it's completely transparent. You shouldn't draw any tile at all there. If it's part of the tile map, that's actually an unchanged tile. The tile map for the background is actually a cache of changes. So a 0 means nothing's changed. Don't change anything. So what we're doing here is we are basically checking to see if that's 0, and if it is, we're skipping. If it's not 0, we're loading that into E. That is going to be our tile number for later. And then what we're doing here is we're loading in the D value, which we loaded in from the tile clear flag. Now, if that is a 0, then we're not going to do anything. If it's a 1, we're going to write a 0 back into the tile map, and that's for when we're drawing the cache. When we're drawing the sprites, we don't want to do that, otherwise we'd wipe the sprites. But if we're drawing the cache, we want to clear that cache so we don't draw it again next time. So that's why we're doing that here. And then what we're doing here is we're moving across to the next tile. We're waiting for a H or V blank so that we can actually write to the tile map. And then we are writing the tile number to the tile map in HL here. Now this E part here is the tile number. HL is the VRAM destination. That will start from 9800 if we're drawing the entire screen. It's calculated if we're drawing from the sprite. So that has set the tile on the classic Game Boy, but we want to use the Game Boy Color functionality, and so we're using that here. So here we're banking in the Game Boy Color equivalent extra bank of VRAM, and the extra byte of data is at the exact same HL address, which is quite convenient for us. So all we're doing here is we would say writing to palette 0 here. So we're using palette 0 for all of our tiles here. And then we're turning off the GB color extras there. Now that might not seem very useful, and it's not really that needed in this case. However, it is needed when we are potentially using XFlip in some cases, and so we would use that there. Now here is the code to actually repeat. So IYL in the simulated registers here is the tile count. So we're repeating until we've done the entire strip. Now once we've done the entire strip, we're writing back the new tile address into the shadow register of BC for the rest of the code and then returning. Now first, before we look at the reverse version, let's take a look at the get screen pos function. Now all this is doing is it's taking an X and Y coordinate and calculating the VRAM destination for the equivalent tile. Now all of my tutorials these days, I use this logical unit system that I've come to work with, and that means a pair of pixels is one logical unit. Works far better on 8-bit systems with the various screen sizes, I find, and most systems can't work very easily with a granularity of 1 pixel anyway, so pairs of pixels is usually over-optimistic at the best of times. Okay, anyway, what we're going to do here is we're going to effectively calculate the Y position times 32, because there's 32 tiles in the tile map on the Game Boy. The visible screen I think is 20 tiles wide, but the actual tile map is 32 tiles, so we can allow for scrolling. So we're calculating the Y position multiplied by 32, adding the X position multiplied by 1 of course, and then we're adding the 9800 VRAM base of the tile map there to the H part. So that has calculated the VRAM destination, and that's used for the sprites because they start at random positions. Drawing of the tile map is using just this fixed screen base here, which is fixed on this system. So that's how we're doing the regular tiles. We also have an XFlip reverse version. This was because this code was originally designed to write a little chibi fighter game, a simulated fake version of Street Fighter. It was a little joke game I wrote, and so that needed horizontal flipping but not vertical. For this stage it seemed too much work adding that much extra functionality to every system. I'm working on a more advanced version called Maxtile, which fixes some of the graphical glitches with this version of the code, and it also allows for Y-flip hardware sprites, transparency juicy things like that. So this is a sort of stopgap measure, just as a simple minimal version that did the bare minimum for the game I was writing at the time, and I learnt things along the way that I'm improving in the Maxtile version. So anyway, so what we've got here is the equivalent version that does a horizontal flip of the tiles. Now the way it does this is using the Game Boy Color's hardware. So most of the code here is exactly the same as before. We're just moving backwards in the tile map, decrementing BC instead of incrementing it. And then we are writing the tile number, the same pattern as before. The only difference is now once you page in the Game Boy Color special data, we are setting this flag here, which is the horizontal flip. And if you wanted Y flip as well, you could set that flag as well, which would do vertical flip. So very straightforward there to do X and Y flip on the Game Boy Color. On the Game Boy Classic, not so much. You would actually have to have a second copy of the pattern data or redraw the pattern data on the fly. So outside of the scope of this, I will have a go at doing that on the Maxtile version. I think I will try and do it for that version, but at this point it's not. It's outside of what I was trying to achieve. So anyway, that is the only difference for X-flipping the tiles on the Game Boy Color because of that extra functionality. We don't really have very much of a job to do, so there we go. Anyway, that's all we got today. If you like what you see, please like and subscribe and stick around because, as I say, I will be doing a more advanced version later on with more functionality. But if you're just getting started, this is I think this is a good starting point if you need sort of basic scrolling and objects moving around the screen. As I say, I will be doing a more advanced version later, but the code is actually very complicated already for the tile map routines. If you want something simpler, please see my Grime tutorials, Grime Z80. That was a multi-platform game that didn't use a tile map because I wouldn't call it tile map because it couldn't scroll as such, but it did allow for caching of graphical data drawing to the screen, a bit like a sort of character map, if you will. And that was much simpler, and actually the graphical routines in that were the basis for these tutorials. So say if you're looking for something really simple that's not as complex as this, take a look at that. Anyway, you're welcome to use any of my code in any way you can. Thanks for watching, and goodbye.